Welcome back, and in this short video we're going to be looking at balancing and writing equations, and then we're just going to have a quick look at some test tube reactions. Okay, so we're on page 9 of your notes. We're just looking at writing equations. Now in GCSE level you will have written a lot of word equations. You'll never write a word equation in A level. Anytime they ask you for an equation, it's always a formula equation. So the first thing I'm going to do is I'm going to replace my words with formula. Now the formula for sodium carbonate is Na2CO3. Sodium's 1 plus, carbonate 2 minus. Hydrochloric acid is just HCl. And they form 3 products. First one is sodium chloride. Then I also have carbon dioxide and water. Now you'll have spotted that these do not balance at the moment. So the next step is to balance the equation. We'll have 2 sodiums on this side, so I need 2 sodiums here. So I'm going to put a big 2 in front of the sodium chloride. I've now got 2 chlorides here, so I need 2 chlorides on the other side. And then I'm going to check the other elements. So I've got 1 carbon, 3 oxygens, where I've got 1 from there and 2 from the carbon dioxide. And I've got 2 hydrogens, and there are my 2 hydrogens. The last step is to put in the state symbols. Now sodium carbonate could be an aqueous solution or it could be a solid. In this case I'm just going to have it as a solid, so it just gets a symbol S. Hydrochloric acid is always aqueous. If it was gas, it would be hydrogen chloride, which is slightly different. Now you should know that sodium chloride is soluble in water, so that becomes aqueous. Water is a liquid, so it's symbol L, and carbon dioxide is a gas. And there I have my balanced stoichiometric equation. Now do remember this gives us the reacting molar ratios. It doesn't tell us the amount of substance I've got present. All it's telling us is the ratio in which things react. 1 to 2 to 2 to 1 to 1. So we're on page 10 of your notes. We're just looking at writing some balanced equations. So I've got sodium chloride reacting to form sodium chloride. So sodium, Na, plus chlorine, which is Cl2, and because it's a diatomic molecule, and that reacts to form sodium chloride, NaCl. Now it's tempting to put a 2 here by the chlorine, or the chloride now, but that would change the formula, and we never change the formulas. But what I can do is have 2 in front of the formula to say it's a molar ratio of 1 to 2. So I've got 2 sodiums, so I need 2 sodiums on this side, and that is now a balanced equation. And there are the rest of them. So do be careful with diatomics, like nitrogen, here, and making sure things balance and you have the correct formulas. So we're on page 11 of your notes. So we're looking at these 4 little test tube reactions. In this first test tube I have some sodium chloride, and I'm just going to add a few drops of silver nitrate. You can see there I form a white precipitate. It's quite a powdery white precipitate, and that's indicative of a silver halide, in this case silver chloride. In the next test tube I've got copper sulfate solution, and I've added a little bit of zinc. You should see the colour of the solution fade and the metal at the bottom become a reddy brown colour. You can see the colour faded and hopefully the metal at the bottom. In the next test tube I'm going to add a few drops of acid to my carbonate solution. You should see it fizzing. You can see it fizzing as I'm adding some acid. And in the last test tube, I have some hydrochloric acid, and I'm just dropping in a small piece of magnesium. You can see there vigorous effervescence, so the magnesium is reacting with the acid, and it's getting quite warm. Eventually all of that magnesium will have reacted. The gas coming off in this case is hydrogen. So there's the magnesium reacting with the hydrochloric acid. You can see the magnesium floating on the surface and reacting quite vigorously. There's my acid being added to my carbonate, and you can see the effervescence as carbon dioxide is being given off. Adding silver nitrate to sodium chloride produces this white precipitate. So here are the equations of the reactions we've just done. So in the test tube 1 you saw a colourless solution. Do make sure you know the difference between colourless and clear. Clear means you can see through it. So that copper sulfate solution was a clear blue solution, and the solution turned colourless. It was clear all the way through. Effervescence, or bubbles, is the observation. Becoming hotter is not technically an observation. It's a useful thing to note, but it's not an observation. Observations are what you can see. And do be very careful with effervescence. We see effervescence, we see bubbles, we conclude that a gas has been given off. But we can't see a gas. We can only see bubbles or effervescence. So be very careful on that one. It's a classic mistake that students make. So that was quite a short video today, just looking at writing and balancing equations and some test tube reactions. In the next video, we're going to be going on to look at calculating the formula from experimental values, and that's in the next video. So until then, take care, stay safe, bye bye.